The problem is merge sorted array. You are given two integer arrays, names1 and names2, sorted in non-decreasing order. So we don't think about it is sorted or not. And two integers m and n represented the numbers of elements in the number ones and names2 respectively. Okay, m is num1 and n is for nums2. So we need to merge those two arrays, num1 and num2, in the single array sorted in a non-decreasing order. The final sorted array should not be written by the function, but instead be sorted inside the array nums1. So it is given nums1 and num2, but we have to solve the three value, only 6. But the nums what has the length 6 is already have that, so we don't need to create a new array that will have 6 length, right? Which length is should not be 6, so the num1 is already being 6, so we don't have to create a new arrays. So we're gonna think about the logics, right? So now in this case we have 1 2 3 and 0 and 0 and 0 for num1, and num2 is 2 and 5 and 6. So normally we can simply think we can copy those three into this numbers array, right? We can copy this to this, then we will sort number ones. So the complexity will be the copy, the arrays, and then the sorting, right? The significant is in sorting. Sorting algorithm will take the n log n, right? So if it is k, we have to spend k log k. But here it is saying that can you come out with an algorithm that runs in order of m plus n time. So m plus n time means if it is m is 3, if it is 3, so it should be the numbers of length, one length. If it is 3 and 3, the one only order of 6. So okay, so we can use two-pointer approach. Two-pointer approach means we will point, like for the number ones, I would put L1 index and then L2 index. We will start from the last value. I will convert the last value and then this last value. Okay, which value is bigger than that? Now 6 is bigger, right? So if 6 is bigger, so how can I do this? The way I'm gonna do is 1 2 3, we have 0 and 0, and the last one will be 6. And then we move the L2 index to the 5 and 3, we will compare that, and then 5 is bigger than that. Okay, we will put this 5 here, and then we'll move to this one. Okay, 2 and 3, which one is bigger? 3 is bigger, so we'll put 3 here. So we will move L1 index from 3 to 2. 2 and 2 is equal, we can take any of them, 2, and then another one is 2, and then another one is 1, right? So if there is no L2, we don't have to do anything. Only if we have L numbers 2, I mean if n is greater than 0, we have to merge, right? If we don't have anything in n2, here the case number 2, we don't have to do anything, and we can the number 1 is already solved, right? So let's do that logic. So I'm gonna create a new index. The index for I1, index for number 1 is I1, because m is just the length. If we want the last index, we have to minus 1 from the length of the array, and index 2 for the numbers 2 and minus 1. And then our reset index is starting from m plus 1, m plus n minus 1. So if it is 6, we will have the last index. Then y n greater than equal 0, we will loop that if if okay, n is greater than 0. Oh, no, n is greater than 0. So n, if n is 1, right? So we have to we have to check whether I2 index 2 is greater than 0. We will do another step. We will merge it, right? So if I1 greater than 0, greater than or equal, right? We will do the equal, right? Okay, 1 and numbers 1 dot index 1 greater than numbers 2 index 2. If it is greater than, we will do numbers 1 I equal numbers 1 I 1. Then we will make minus, right? Okay, so what if it is now less than that? We will do I2. So that's it. So let's see what happened. And 2 and 2 and 1. Yes. Oh, I didn't click it. Okay, cool. What if it is, this one is 1 on 1, if it is 0, we need to return 1. Cool. Okay, that's it. Thank you.